All right, this is Unit 3, Lesson 5, Zeros of Polynomial Functions. Our less than essential question is, how are the zeros of a polynomial function related to a function's equation and graph? So at the end of this lesson, you'll be able to model and solve problems using the zeros of a polynomial function. All right, example 1, use zeros to graph a polynomial function. So what are the zeros of f of x equals x times x minus 4 times x plus 3? Graph the function. So a zero of a polynomial function is a value for which the function is equal to 0. By the zero product property, the zeros of the function are -3, 0, and 4. Okay, so if I set each of my x values equal to 0, x equals 0, x minus 4 equals 0, I add 4 to both sides, so I get x equals 4, and x plus 3 equals 0, so x equals -3. The zero divide a number line into 4 intervals: 1, 2, 1, 2, 3, and 4. Okay. To see how the graph of the function behaves on each interval, look at the sign of each factor on each interval and the sign of the product. The last column shows the sign of the product of the 3 factors. Okay. So when x is less than -3, x is negative, x minus 4 is negative, x plus 3 is negative, so the product's negative. Between -3 and 0, negative, negative, positive, which gives us a positive. And then 0, x, 4 is positive, negative, positive, which gives us a negative. And then x is greater than 4, positives across the board gives us a positive. Sketch the graph, draw a continuous curve that passes through each zero on the x-axis and is below the x-axis when the function is negative and above the x-axis when the function is positive. So if I look at -3, it's negative. Between -3 and 0, it's positive. Between 0 and 4, it's negative, and 4 and beyond, it's positive. All right, so let's try it. Factor the function, then use the zeros to sketch its graph. So with this, I can factor out a 4. So I'm left with x cubed plus x. Actually, I can factor out a 4x, which gives us x squared plus x minus 4, 6. Okay, so then I have 4x is x plus 2 and x minus 3. Okay. So that means gives me zeros at x equals 0, x equals -2, and 3. Okay, so I have one at -2, at 0, and at 3. Okay. All right, so it's going to be negative before, okay, positive from here to here, negative, and then positive again. That's a really, really awful drawing. All right, factor the function, then use zeros to sketch its graph. So I have x to the 4th minus 81. So 4th root. 3 to the 4th is 81. So this is going to be x squared minus 9 and x plus 9. So x equals 3 and -3. Okay. So -3 going to be positive. It's going to come down like this. I'm going to do something like this. And go up like that. All right, example 2. Understand how a multiple 0 can affect a graph. How does a multiple 0 affect the graph of a polynomial function? So one of the zeros of the polynomial function f is 1. Use the tool to explore how the multiplicity of this 0 affects the graph. When the multiplicity of a 0 is odd, the function crosses the x-axis, and when the multiplicity of a 0 is even, the graph has a turning point on the x-axis. So here's it at 0. At 1, it crosses. At 2, there's a turning point. 3, it's odd. Crosses. 4, there's a turning point. 5, it crosses. 6, there's the turning point. Okay. Describe the behavior of the graph of the function at each of its zeros. So I have x, x plus 4, x minus 1 to the 4th power, which means negative, or x equals 1 has a multiplicity of 4. Okay. So the graph crosses the x-axis at the zeros -4, 0, and has a turning point at the 0, 1. Okay, so remember, if it's an odd, it crosses, and if it's an even, it has a turning point. Okay. So I have x squared plus 9, x minus 1 to the 5th, x plus 2 squared. So this -2 has a multiplicity of 2, 1 has a multiplicity of 5. So the graph crosses the x-axis at the 0, 1, and has a turning point at the 0, -2. Odd, even. All right, example 3, find real and complex zeros. What are all the real and complex zeros of the polynomial function shown in the graph? So use the graph to determine one of the zeros of the polynomial. The function appears to cross the x-axis at x equals 2. So if I look at the graph, it appears to cross right here at x equals 2. I can confirm that 2 is the zero of the function. F of 2 equals 2 cubed plus 2 squared minus 3 times 2 minus 6 does equal 0, so it is a 0. So 2 is a 0 of the function. By the factor theorem, x minus 2 is a factor of the related polynomial. So step 2, I use synthetic division to factor the polynomial. This gives me x squared plus 3x plus 3 times x minus 2. Step 3, I use the quadratic formula to find the remaining zeros because I don't know what the factors are for this. Actually, there's no real factors there. Okay, so I get -3/2 plus or minus the square root of 3 over 2i. So the zeros of the polynomial function f are 2, -3/2 plus the square root of 3 over 2i, and -3/2 minus the square root of 3 over 2i. All right, so let's try it out. What are all the real and complex zeros of the polynomial function shown in the graph? I have f of x equals 2x cubed minus 8x squared plus 9x plus 9. Well, it looks like it crosses at 3. I can always double check. So 3 equals 2 times 3 cubed minus 8 times 3 squared plus 9 . 9. Okay. 3 cubed times 2 minus 8. It's 54 minus 8 times 9. Gives me -18 plus 9 times 3, which gives me 9 minus 9, which is 0. Equals 0, so that is. I then use synthetic division. When I do synthetic division, I get that. so that gives me x minus 3 times 2x squared minus 2x plus 3. Right, and then I need to use the quadratic formula. So negative b plus or minus the square root, b squared minus 4ac all over 2a. So I get that. X equals 3 and x equals 1 plus or minus the square root, actually I square root 5, and all of that over 2. Number 3b, what are the real and complex zeros of the polynomial function shown in the graph? So I have x to the 4th minus 3x squared minus 4. So I have x to the 4th minus 3x squared minus 4. It looks like it crosses at negative 2 and 2. So I'm going to try 2 first. So f of 2 equals 2 to the 4th minus 3 times 2 squared minus 4. 2 to the 4th minus 3 times 2 squared minus 4 does give me 0. Okay. So then I can use synthetic division. Okay. So that gives me x cubed plus 2x squared plus x plus 2. And then I can also double check negative 2. So that gives me x minus 2, x cubed plus 2x squared plus x plus 2. Here's my synthetic division for that. Okay. So with that, I can double check and see if negative 2 works. So I'm going to go ahead and do the synthetic division. 0. That also works. So that gives me x squared plus 1. So there's the second synthetic division. So that gives me x minus 2, x plus 2 times x squared plus 1. So when I solve these, I get x equals negative 2, 2, I, and negative I. All right, example 4, interpret the zeros of a function. So Acme Innovation makes and sells lamps. Their profit P in hundreds of dollars earned is a function of the number of lamps sold X in thousands. From historical data, they know that their company's profits is modeled by the function shown. What do the zeros of the function tell you about the number of lamps that Acme Innovations should produce? So there's a 0 here, here, and here. Okay. So Acme Innovations wants a positive profit. This corresponds to where the graph is above the x-axis. To find where the function crosses the x-axis from negative to positive values, find the zeros of the function. So it looks like negative 2, 3, and 10 are my zeros. Based on the graph, the zeros of the function appear to be negative 2, 3, and 10. If these are the zeros of the function, then by the factor theorem, you can determine the factors of the related polynomial. I multiply these factors to verify that the product is equal to the polynomial given. X plus 2 times x minus 3 times x minus 10 does in fact give me the polynomial that they gave us at the top. Okay. The result is equal to negative p of x, not p of x, but both polynomials have the same factors since p of x equals negative times x plus 2 times x minus 3 times x minus 10. The zeros of p are indeed negative 2, 3, and 10. So when P of X is positive, Acme Innovations earns a profit. The profit is positive when X is less than -2 or 3 is less than X is less than 10. Acme Innovations cannot produce a negative number of lamps, so you can disregard the interval X is less than -2. Since X represents the number of lamps in hundreds, the company should make between 3,000 and 10,000 lamps. Okay, so Acme Innovations makes and sells lamps. Their profit P in the hundreds of dollars earned is a function of the number of lamps sold, X in thousands. Due to a decrease in the cost of materials, the profits function for Acme Innovation has changed to Q of X equals negative X cubed plus 10X squared plus 13X minus 22. How many lamps should they make in order to make a profit? Okay, so I need to find the zeros for this function. So I have negative X cubed plus 10X squared plus 13X minus 22. All right, so when I factor this out, I get -1, X plus 2, and X minus 11. So when I factor it, my zeros are 1, -2, and 11. I can ignore a -2 because I can't make negative lamps. So I have between 1,000 and 11,000 lamps. All right, example 5, solve polynomial equations. What are the solutions of 2x cubed plus 5x squared minus 3x equals 3x cubed plus 8x squared plus 1? So I can rewrite the equation in the form P of X equals 0, and then I combine my like terms on one side of the equation. So I get x cubed plus 3x squared plus 3x plus 1. Okay, now I find the roots of the equation. The roots are the zeros of the function. So x cubed plus 3x squared plus 3x plus 1 is the cube of a binomial. So x plus 1 cubed, so x plus 1 equals 0, or x equals -1. The solution of the equation is x equals -1. So let's try it out. What is the solution of the equation x cubed minus 7x plus 6 equals x cubed plus 5x squared minus 2x minus 24? So I need to write this so it equals 0. So I have x cubed minus x cubed minus 7x minus 5x squared plus 2x plus 6 plus 24 equals 0. So that gives me negative 5x squared minus 5x plus 30 equals 0. I can factor out a 5. So when I do that, I get negative x squared minus x plus 6. I can then factor that from there. So I can actually factor out a negative. Let's do -5. Okay. Gives me a positive 6 and a negative 6. Okay. So that means to get a positive x plus 3, x minus 2. Okay. So my zeros are -3 and 2. Okay, so then I have x to the 4th plus 2x squared equals negative x cubed minus 2x. So I get x to the 4th plus x cubed plus 2x squared minus 2x equals 0. I can factor out an x. So I get x cubed plus x squared plus 2x minus 2. Okay, from here, should be able to factor out a 1.
I'll have your computer too in the office.
And then I should get x times x plus 1 times, times x squared plus 2. Okay, so when I set that up, x squared plus 2 equals 0. I get x squared equals -2 square root. X equals plus or minus I square root of 2. Okay, so that's x equals 0, -1, and then I square root 2 and negative I square root 2. All right, example 6. Solve a polynomial inequality by graphing. What are the solutions of x cubed minus 16x is less than 0? So the solution are all values of x that make the inequality true. The polynomial x cubed minus 16x defines a polynomial function x cubed minus 16x. I use the zeros of p factor to find the zeros of the function. So x cubed minus 16x is x times x squared minus 16. Well, this is a difference of 2 squares. So I get x times x minus 4 times x plus 4. So at zero product property, the zeros of p are -4, 0, and 4. I can then sketch and use the graph to determine where p of x is less than 0, or where the graph of p is below the x-axis. So blue portion shows where p is above 0, and the red shows where p is below 0. So solutions of the inequality x cubed minus 16x is less than 0 are all real numbers such that x is less than -4, or 0 is less than x is less than 4. This section right here. All right, so let's try it. What are the solutions of the inequality? 2x cubed plus 12x squared plus 12x is less than 0. So I'm going to go ahead and factor out an x. So I get 2x squared. Actually, I'm going to factor out a 2x. So I get x squared plus 6x plus 6. Okay. So that's 2x, and then x plus 1x plus 6. So that means x equals 0, -1, and -6. Okay, so x squared plus 6x plus 6 does not factor nicely, of course. So when I factor it, I'm actually going to have to use the quadratic. So when I do that, I'm going to get 2x. So x equals 0. And then the -3 minus the square root of 3. And -3 plus the square root of 3. Okay, so I get x is less than -3 square root 3 minus 4 -3 plus square root 3 is less than x is less than 0. Okay. Letter B, I have x squared minus 1 times x squared minus x minus 6 is greater than 0. So x squared minus 1, okay, that's the difference of 2 squares. So that gives me x plus 1, x minus 1. And then x squared minus x minus 6 gives me x minus 3 times x plus 2. Okay. So my zeros are -1, 1, 3, and -2. So x is greater than -2, or -1 is less than x is less than 1, or x is greater than 3. All right, so concept summary, zeros of polynomials, f of x equals x minus a squared times x minus b cubed times x minus c. Multiplicity of 2 has a turning point at the x, so it touches and then bounces off. The zeros are a, b, and c. A has a multiplicity of 2, b has a multiplicity of 3, so it crosses the x-axis. C has a multiplicity of 1, so it crosses the x-axis there. And that is the end of Unit 3, Lesson 5.